For neurotransmission, we're going to be looking at the role that neurotransmitters play in the onset or the etiology of depression. Now, neurotransmission was actually the very first theory that gained a lot of traction regarding what caused depression. A few decades ago, this was the first pathophysiological explanation for depression. There was a lot of excitement around this theory because what they kind of by happenstance found is that monoamine antagonists, so these are going to be things that block the work of serotonin, dopamine, or at least block their reuptake. So it keeps dopamine, serotonin in the system longer. What they found is that those were clinically effective antidepressants. They weren't using them to treat depression, but that was a secondary outcome. So that led to psychologists, psychiatrists paying much more attention to the role of serotonin, dopamine, norepinephrine, all those monoamines, to look and see what role they may have in depression, because medications that increased the amount of neurotransmission of those monoamines showed a decrease in depression. However, that primary theory has lost a little bit of favor. There's certainly still a lot of research that shows that monoamines play a role, but it can't stand alone as a sole theory for explaining depression. And there's a couple reasons for that. One is that individuals who do take medications that improve monoamine functioning, they don't all show improvement in depression. So that's going to be one hole in that argument. Another hole in the argument is that when you take medications for serotonin, dopamine, norepinephrine, they work on those neurotransmitters immediately. So you're going to see changes in those neurotransmitters immediately, but individuals take 3 to 4 weeks to improve when they're on medications, and that just doesn't translate. We should see more immediate effects if it was really solely related to those neurotransmitters or needing more of a neurotransmitter. Now, another reason that we're going to look at is other treatments which have nothing to do with the monoamines have shown to have efficacy in treating depression. So, for example, ketamine, that acts on, it's an antagonist for NMDA, which deals with glutamate and GABA, and it helps with depression. So we can't look at this as solely a monoamine factor, but we are going to look at neurotransmitters in general and see what kind of impact they have on depression. So again, it's not simply a matter of there not being enough serotonin. One more piece of evidence that would poke a hole in the serotonin theory is that a lot of research does show that when individuals are given medications that increase their serotonin levels, they have antidepressant effects. However, other research has looked at when you deplete someone's serotonin. There was actually a study done recently where they used a certain substance that depleted the individual's dopamine, serotonin, and norepinephrine by 95%. And only 15% of those participants in that study showed antidepressant or mood effects. So therefore, obviously, simply decreasing monoamines does not explain why individuals have depression. So if I've made a case for that, let's look at what role do they have in understanding depression. So when we look at serotonin, this has gotten a lot of traction. Again, there is a belief that there is decreased serotonin, but that's just not the whole picture. So serotonin plays a really big role in affective regulation. In fact, when we see decreased amounts of serotonin, we tend to see that there is more cognitive biases toward looking at more negative stimuli. Like that's something that happens when we see decreased serotonin. So there's some negative priming that goes on. Also, serotonin plays a role in neurogenesis. So when we see decreases in serotonin, we're seeing decreases in neurogenesis. The next neurotransmitter we'll talk about is norepinephrine. Norepinephrine is significantly associated with our sympathetic response to stress. So when we experience stress, we see increases in the amount of norepinephrine that is produced along with cortisol. Those tend to go hand in hand. And when we see increases in norepinephrine and cortisol, that tends to produce some types of neurotoxicity in the body, which has been thought to be associated with depression. The next neurotransmitter that we'll discuss is one that you should hopefully be familiar with. It is dopamine. And with dopamine, what we see here is it is associated with one of the major reward pathways in the brain. And what's believed to be happening is that it becomes an altered pathway such that rewards don't carry the same meaning as they once did. And we'll talk about that more detail here shortly. But before we do, there's one more neurotransmitter that I want to talk about. And this one has recently come into attention because of a certain drug that helps with depression that I've just mentioned. It's ketamine. Ketamine's a drug. Glutamate is a neurotransmitter. So glutamate is more of an excitatory neurotransmitter, whereas GABA is the inhibitory neurotransmitter. And what's believed here is that individuals with depression just don't have enough glutamate production and maybe have too much GABA production, because what ketamine has shown to do as a NMDA antagonist or a GABA antagonist is it helps decrease the amount of GABA production and increase the glutamate production. And when we see increases in glutamate, we also see increases in neuroplasticity. So it's believed that that role of neuroplasticity is helping with the depression improvement. But there's been a lot of focus on the role of glutamate recently in understanding depression because of ketamine's antidepressant effects and how it increases glutamate in our system. Now, the next thing we'll look at is specifically that dopamine pathway I referred to earlier. So what's going on here is that there are several tracts in the brain that are dopaminergic pathways, and the one that we're going to focus on is the mesolimbic tract. And that one, of course, is this one right here. And it starts here in the ventral tegmental area, and it just works its way up through the amygdala, the hippocampus. And what this is focused on, again, is that reward motivation pathway and what becomes reinforced for us. And what is thought to happen is that when dopamine levels are decreased in this pathway, that our drive for reward, our ability to experience reinforcement and reward is just not quite the same. And this would be related to the anhedonia, which I briefly referenced earlier, in that our desire for things changes. And one thing that some researchers have pointed out is that there's actually a difference between the ability to experience pleasure and the drive to want to experience pleasure. So there's a liking, right? Can you experience pleasure? Can you like something? And then there's the wanting. Do you want to experience pleasure? And the idea here is that what they have found is that individuals have a decreased wanting when that dopamine pathway gets a little altered with the amount of dopamine in the system. So again, this comes back to an altered reinforcement system where individuals are less motivated by reward. Again, it's not that they can't experience reward, but their desire to experience reward has been decreased. And there's more of an emphasis on punishment, more negative priming, likely in conjunction with the serotonin changes, which we also just discussed earlier. So hopefully this just kind of provides you an overview of the role that neurotransmitters can play with depression.